Hi, my name is Nurzahida AZMI. My matrix number is D2023110768. So, we are from Group 5 and we want to present about Malaysian culture, arts and geometry. So, our group choose topic is stone sculpture. First, we go through about the location of the sculpture. So, for the exact location of the sculpture is at Laman Arca, University Pendidikan Sultan Idris. Okay, you can see this is Laman Arca near the INC International Mobility Center. So, the Laman Arca is easily accessible and well maintenance. It's open green space with artistic display and suitable to environment and observation or measurement. Okay, as you can see, this is the old Laman Arca, which is the Sekolah Dato' Abdul Razak. So, the area where Laman Arca located is formerly part of the classroom and administration block of Sekolah Dato' Abdul Razak before becoming a part of the UPSI campus. Okay, so the surrounding view Laman Arca has a pathway around the park, green landscape, and nearby So for the next, we go to the usage and the function of the sculpture. You can see the artistic value on the sculpture, which is enhance the visual appeal of the UPSI sculpture park and create an attractive outdoor environment. So next, it's a public artwork serves as a landmark within a Laman Arca and represent creativity and artistic expression. The sculpture is also can be used for the education resource because it supports learning in art, design and mathematics and allow direct observation of the geometric element. Lastly, it also can have a geometric application, demonstrate cube-like form and circular opening, and useful for studying management, symmetric and value. We go to the size and dimension of the sculpture. Okay, so you can see the sculpture is cube-like shape. Okay, so each side of the cube-like shape sculpture measure approximately about around 120 cm. So for the circular opening, the top opening outer diameter which is 50 cm and inner diameter. The inner diameter is about 30 cm. So for the rear opening behind the structure, the diameter is about 35 cm. Okay, next we go to the diagram of the sculpture. So we have a 4 view. Okay, first is a front view, second is a side view, third is rear view or a behind view, and the last of the top view. Okay, so I will pass the presentation for the next presenter.
Okay, let's move on to the geometric shape of this sculpture. As you can see, the main body of this sculpture is cubic, because you can see it has a 6 square faces and it's balanced diagonally on its part. Next to the structure of this sculpture, the most obvious shape that we can find is the square, because each faces of this sculpture have square faces, and from the front view we can also see a circle shape, which is this at the middle, and from another view we can see another shape, which is first of all isosceles trapezium here in the middle. This shape is isosceles trapezium because it has a congruent legs and a congruent base angle. And lastly, the last 2D structural shape that we can form in this sculpture is a triangle. As you can see from these faces, you can see a triangle over here and over here actually. Okay, next I will pass to the next presenter to explain the geometrical concept.
I will explain the geometrical concept and measurement of 3 shapes, which are the cube, square and the circle. First, let's take a look at the cube. Cube is actually a 3-dimensional shape which consists of 12 congruent edges. So, since all edges have equal measure, therefore each measure is 120 centimeters. Every face of the cube is actually a square. Therefore, each angle of each face has a right angle, which is measured is 90 degrees. The perimeter of the cube is sum of the length of all its edges. So by using the perimeter formula, we obtain that the perimeter of a cube is actually 1,440 centimeters. The area of the cube is the sum of areas of 6 congruent square faces. So by using the area formula, we obtain that area of the cube is 86,400 centimeters square. Since a cube is 3-dimensional shape, therefore it has the volume. So by using the volume formula, we obtain the volume of the cube is actually 1,228,000 centimeters cube. Next, let's discuss about the square. Square is a type of quadrilateral that have 4 congruent sides. So the number of sides of the square is 4. According to culinary 4.241, all sides of the square are congruent. So in this case, the side length of the square is 120 centimeters. The square is also type of rectangle, where all 4 angles in the square is a right angle measuring 90 degrees. The perimeter of the square is the sum of the length of all sides in the square. So by using the formula, we obtain the perimeter of the square is 480 centimeters. The area of the square is actually the square of the length of all sides in the square. Therefore, by using the area formula, the area of the square is 40,000 1400 centimeter cube. Unlike the cube, a square is two-dimensional shape, so it does not have a volume. Now, let's take a look about the circle. Circle is two-dimensional shape that has no side because the circle does not contain any line segment. So the numbers of sides in the circle is 0. The diameter of the circle is line segment that passing through the center of the circle, while the radius is distance from the center to the edge of the center. Angle of the circle is the sum of the measure of the consecutive arc that forming a complete circle is 360 degrees. So the complete angle around the circle is always 360 degrees. The perimeter or circumference of a circle is given by pi multiplied by perimeter or pi multiplied by 2 with the radius. Based on 3 circular openings, we obtain that the circumference of the circle is approximately 157 centimeters, 94.25 centimeters, and 28.5 and 28.54 centimeters. The area of the circle is given with a radius r is given by pi multiplied by the square of the radius. Based on the diameter of 3 circular openings, we obtain that the area of the circle is approximately 1,163 centimeter cube, 206 centimeter cube, and 490 centimeter cube. A circle is two-dimensional shape, therefore it does not have a volume.
Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Muhammad Amin bin Abdul Hadi, and for my part, I will present the geometrical concepts found on the stone sculpture, specifically the isosceles triangle and the isosceles trapezium. These two shapes can be observed on the visible faces on the sculpture. In this section, I will explain the size, length, angle, parameter, area and volume. I will also relate to the measurements to the geometric concept that we learned in class. We move to the first part, which is isosceles triangle. An isosceles triangle is a triangle that has two congruent sides. Based on the diagram, the left side and the right side of the triangle are equal in length. The left side is labeled as A equals to 68 cm and the right side is labeled as C equals to 68 cm. The base of the triangle is labeled as B equals to 120 cm. This shows that the shape is an isosceles triangle because two of its sides have the same measurement. For the angles, the two base angles are congruent. In this diagram, the left base angle is 28 degrees and the right base angle is also 28 degrees. Since the sum of the interior angle of a triangle is 180, so the top angle can be calculated as. Therefore, the top angle is 124 degrees. This confirms the triangle angle property that the sum of the interior angle in a triangle is 180. So the parameter of a triangle is the sum of all sides lengths. So the formula is P equals to A plus B plus C, and then we substitute all the value inside the formula and we will get the parameter value. So next part is the area of the triangle. So we will use this formula to calculate the area, which is A equals to 1/2 base times height. So this formula is based on the theorem that the area of the triangle is half of the product of its base and the corresponding height. So the base of the triangle is 120 cm and the height is estimated as 32 cm. So we substitute this value inside the formula and we will get the area. So now we will move to the second shape, which is the isosceles trapezium. This shape can be seen on another visible face of the sculpture. An isosceles trapezium is a quadrilateral with one pair of parallel opposite sides. These parallel sides are called the bases. In an isosceles trapezium, the two non-parallel sides are congruent. Based on our label diagram, the top base is 120 cm and the bottom base is 68 cm. The left slated side is 40 cm and the right slated side is also 40 cm. This shows that the non-parallel sides are equal, so the shape can be classified as an isosceles trapezium. For the angle, a quadrilateral has a total interior angle of 360 degrees. In an isosceles trapezium, each pair of a base angle is congruent. From the diagram, the top left angle is 49 degrees and the top right angle is also 49 degrees. The bottom left angle is 131 degrees and the bottom right angle is also 131 degrees. We can check the total interior angle by sum all the angle. So next is the parameter. So the parameter of a polygon is the sum all of its side length. So the formula is, so we substitute all the value inside the formula and we will get the parameter value, which is 268 cm. For the area of the trapezium, we use this formula, which is A equals to 1/2 times height times base 1 plus base 2. This formula is based on the theorem for the area of a tripodsquad, where B1 and B2 are the two bases and the h is the altitude or height. In this case, the height is estimated as 30 cm, the first base is 120 cm and the second base is 68 cm. So we substitute this value inside the formula and we will get the area of the isosceles trapezium, which is 2820 cm square. Similar to the isosceles triangle, the isosceles trapezoid is also two-dimensional shape, therefore it does not have volume. In conclusion, the stone sculpture contains clear geometrical features that can be related to real-life mathematical concepts. The isosceles triangle shows the property of two equal sides, equal base angles, parameter, and triangular area. Meanwhile, the isosceles trapezium shows one pair of parallel sides, congruent non-parallel sides, supplementary angle relationship, parameter, and trapezium area. This analysis proves that geometry is not only found in textbooks, but also in real objects such as sculpture around us. So that's all from me. We move to another presenter.
Hi and Assalamualaikum. So my name is SYAHMI bin ADNAN. So today I will explain about transformation in motif and pattern. So what is transformation? The transformation is a process that changes the position, orientation or size of a shape. So our group will choose a stone sculpture because it has various motif and pattern that show the geometric transformation. So So what is a motif and pattern? A motif is referred to the single decorative element on the sculpture, while a pattern is referred to the organized arrangement of repeated motifs. So in this stone sculpture, we have identified a four transformation, which is translation, reflection, rotation, and also enlargement. Okay, next we will move to the transformation in motif. So in transformation in motif, we have identified the reflection, rotation, and also enlargement. So first, the reflection, which is as you can see, the circular ring motif on the top surface is symmetric about the vertical line, which is the left half is the mirror image of the right half. And next is the rotation. So the circular ring motif has the rotational symmetry of 4 order at the center point, which is it looks the same on the 10 degrees, 90 degrees, 180 degrees, and also 270 degrees when it rotates about the center. So next is the enlargement, which is the outer circular ring motif. We can view the outer as the enlarged version of the inner circular ring, which is the both circle have the same shape and also center, but it different in size. Okay, next we move to the transformation in pattern. So the transformation in pattern that we have identified on the stone sculpture, it has a rotation pattern, reflection pattern, and also translation pattern. So first is the rotation pattern, which is the texture motif that we can see on the white base was arranged around the center of the sculpture, and it also has the similar motif on the other side, which is when it changes the orientation, you can see the similar texture motif on the white base of stone sculpture. So it is the rotational pattern. So next is the reflection pattern. So the texture motif on the left side and also right side of the stone sculpture is the same, which is we can see that the left side and the right side is the mirror image of each other. So this shows that a reflection pattern across a vertical line. So lastly is the translation pattern. So we can see that the diagonal pattern appear on the first side of the stone sculpture, and we can see the next picture, which is the same diagonal pattern also appear on the different side of the stone sculpture. So this shows that the pattern maintain similar shape and width and orientation while occurring at different positions. So we can see that it is the translation pattern of the stone sculpture.
Okay, to summarize, we have analyzed the stone sculpture at Rahmat USI to bridge the gap between geometrical theory and public art. And from the measurement data, we have verified the core 126 cm cubical structure with a total volume of 1,728,000 cm3. And we have examined 5 2D and 3D shapes and their corresponding properties such as perimeter, area, and angle, and also the volume. And we also successfully identified the transformation that involved in this sculpture, such as reflection, rotational, and translation, and along with enlargement in its concentric motif. To conclude, this study has proved that geometry is not just an abstract formula, but the structural and aesthetic foundation of the world around us. And geometric principles like balance, symmetry, and proportion are essential for creating visually stable and impactful art. And then a direct field observation at USI allowed for a deeper appreciation of how mathematical transformation creates complex, beautiful motif in real life situations. And a final thought, geometry acts as an unseen skeleton of public art, proving that even the most creative expression rely on the structure truth of mathematics.